Hello everybody, David Emily here. I wanted to go over a LeetCode problem. LeetCode just started their problem every day in the month of May, so what an amazing time to hop into it, so I wanted to do that. I am a C# programmer by trade, but I know I learned C in school, and I know a lot of other people learn just C in school, and I don't want not knowing a language to hold you back from doing these problems. So I wanted to do these problems in C. So this very first problem is called First Bad version. And it's this idea of source control, and we have versions of it. So we'll have like version 1, version 2, version 3, version 4. This is just an example. But let's say that if version 2 is bad, so if this is bad, that also means 3 and 4 is bad. Likewise, if none of them could be bad, all of them could be great, 4 could be great, but generally you're not going to have like a bad and then like a good. So this problem is going through, you're going to be using this method they give you called isBadVersion. Returns either a true or false depending on if it's a bad version or not. So I want to go over some strategies on this. The most natural way to do it is to come in here and just start like int I equals 1 and just iterate through and find the first bad one. So you could do that, brute forcing it. You could easily do that. Another way is to say like, oh, well, if it's source control, people error, like probably the back one is the best or like the most likely to be wrong if any of them are. So to work from the back and go down. Great for first idea, not going to be quick enough to pass this example though. For this you'll want to do what they call binary search. So much like how you read a phone book, you don't like start from page 1 and see if someone's whose middle name starts with an M is there. You'll start in the middle of the phone book and see like, oh, where am I at? Oh, I either go to this half or this half. So we're going to take this strategy and we're going to go down the middle here, and then we're going to check this one. And if it's good, we're going to move up and we're going to check this one. If this one is bad, we are then going to move down and check to see if this one is good or bad. So that's the strategy. Use binary search on it. So instead of, big O notation, binary search is always going to be better because you're just halving everything instead of making it new. So we're going to start with, let's just call it left I equals 1. That way we'll start at the first version. Up here you can see in what they give you that they don't start at 0. So even though arrays start at 0, I guess the versions they're giving us don't start at 0. So we want to start there. We want to make the right equals to n. So we're just going to set up our quadrant so it goes, or thing so it goes down. To follow these, we're going to make a left here and a right here. And then our idea is that every time this runs, we're going to get the middle of these. And then if it's bigger, I'm just going to move this left over here. So then we are checking these two. If it's smaller, I'm going to move the right here. So then we're checking these two. So that's the strategy behind it. So we're just going to say while left is bigger or less than right. So that way this ends when they're both on the same number, because that means if both left and right are here at the same number, so left is now here, if both left and right are 4 and 4 is good, that means there does not exist any bad source control in this array. So we're going to do that, and we're going to say int middle, that sounds good, equals left plus left, right is always bigger than left. So we're going to say right minus left divided by 2. The reason you want to always do this to find the middle of this addition is because if left and right are both really big numbers, there's a chance you could overflow the int and it's going to blow up. So the best way to find the middle of this is to first subtract the left out. So if you have a 5 and a 3, right is your 5 and left is your 3, first subtract the 3 out, so then you have a 2, and then divide that in half, and then add the left back in. That way, your number always stays below the maximum. In this case, right. The right variable. Your number should always stay below the right variable, and that's how you can do it easily on here. So then we want to just run a check on this. So we want to run that if first bad version, we're running this is bad version, and we want to pass in the middle. So this function returns a true if it's bad, yes. So true if it's bad, false if it's good. So I'm going to equal true. This true is not needed, just throwing it in there for readability's sake. And if that's true, we know this number here is less than. So kind of how we talked about earlier, we now want to assign this right here. So we'll go in and do that. So right now equals middle. Okay, and then else, if that's not true, the opposite, we want to move the left over. So let's do left equals middle plus 1. I'm adding this plus 1 in here because this way we always move this up. If you don't do that, you'll never have left and right possible equal to each other. Your end thing will be like this, where left and right are two different numbers right next to each other. I'm choosing the left one because that way we're running to make sure left is always under it. You could also do like a right minus 1. In my mind, I feel like adding is always easier to picture than subtract. And since we are making sure the left one moves up, here at the bottom we want to return left. So run this real quick. Okay, looks good. Let's run against all other tests. Hey, that worked. So let's see how we did here. We are top 100%. So there we go. That's the first bad version problem. The first day of the May LeetCode 30-day challenge. So thanks for joining me, and good luck.